Hello everybody, this is Similar Figures Worksheet. So I made the font, I tried to make it nice and big, and also I'm going to talk extra loud so you can hear me. So for the first part of this worksheet, it's going to be triangles inscribed, which means within other triangles. And then the next part of this is going to be kind of some old stuff that we've been doing in past problems. Okay, just let me take out my jacket. It's been a long day. Okay, so this one here was one of the homework problems from last night. I saw a few students misstep with this problem, so I'm going to go over it now. Let's see, can you see it? Okay, when Mr. Corbett was in 7th grade, sorry, typo, he wanted to climb the tree in his backyard. Mr. Corbett knew that the tree was 20 feet tall, and when he stood 10 feet away from the tree, he cast a 3.5-foot shadow. How tall was Mr. Corbett in 7th grade? Was he shorter or taller than Fernando Mata? Was he shorter or taller than the people's champ? Brandon Green. The champ is here. Brandon Green. All right. Brandon Green. The champ. Okay. Green. Okay. Anyway. So the way that I do these problems, I think we can visualize them like this. This would be a great thing to put in your composition notebook. There's this big triangle right here. There's the big one. So I'll draw that here. It's going to be shrunk down a little bit to scale, I may add. Props to Charlie Escalante yesterday for using scale in class. 4th grade, you know what I'm talking about. And then there's also this small triangle here. I'm going to take that out here. And now I'm going to label everything I know, especially... Okay, especially what I'm trying to solve for, which is this side length here, which is going to be our x, which is also my height. Okay, so in the purple triangle, I know that this is 3.5. And then in the green triangle, I know that the height of the tree is 20 feet. Now, a lot of you set up the proportion thinking that this entire thing was 10.5, but no, it's 10.5 and 3.5, so we need to add these together, which is going to give me a total of 14 feet. So this here is 14 feet. And feet, feet, feet. Okay, so the way that we can set this proportion, 20 over 14 is equal to x over 3.5. Multiply, cross and multiply, then solve for x. So it's going to be 3.5 times 20 is equal to, what did I do here? 4? Yikes, I did the 4 and the 1 backwards. I'm sorry. 14 feet. 14 times x. 3.5 times 20 is going to be 70, equal to 14x. Divide both sides by 14, and x is equal to 5 feet. So I was 5 feet in 7th grade. I was short. I was one of the shortest ones. In basketball, I was the point guard. I was definitely not the forward or center like I am now. Okay, the next problem I'm going to go over. And this is a problem that we have done before, but I do want to go over this one again. I think this is a really good problem. Both of these are very similar problems that are going to be on the IA. So Kristen's perspective drawing, so shrunk down a scaled version of 2 buildings is shown below. In the drawing, the closer building is 4 inches high. The horizon line is divided into 2 sections that measure 8 inches and 3 inches. Both buildings are perpendicular. Both buildings are perpendicular to 90 degrees of the horizon line, to the horizon line. So it asks, well, I cut out the question, I'm sorry. But it asks here, what is the height of the building in the distance, in the further distance? So once again, what we're going to do, there's this big triangle here, and I'll draw right here, to scale, but shrunk down just a bit. There's also going to be this triangle right here. And I'm going to shrink this down to scale. So now I'm solving for this. This is my x. I know that this is 3, so I'm looking at the purple triangle. I know here this is 4. This is given to me. Now this says 8. You may not be able to see it. And this says 3, and this says 4. This distance here is not just 8, because 8 stops here. It stops right about here. This is 8, and this would be 3. So we got to add them together to get the total distance, which is going to be 11. Now, once I set up my proportion, which could be something like this, 4 over 11 is equal to x over 3. It could have been 11 over 4 and, x, and 3 over x as well. So I'm going to cross multiply, bring them down here, which gives me 11x is equal to 4 times 3. I'm just going to come up here because I'm running out of room. So that gives me 12 is equal to 11x. I'll divide by both sides by 11, which gives me x is equal to 12 over 11. And that is my answer, 11 over 12 inches. Excuse me, 12 over 11 inches. Did I cut that out? I'm sorry. Okay, so this is my work here. Okay, so now with these two types of problems, what I'd like you to do, go on and please solve this problem, submit your answer, and then now please go on after this problem. You're solving for x, and here you're solving for EC, which is this distance right here, EC. So solve for here. I'm going to put x there. And please submit your answers. Once you have done that, I'm just about to start. So it's in the same worksheet. I'm just going to go over this one problem right here. All right. Thank you so much for submitting your answers. Okay. Thank you for submitting your answers. 3G. This is the next guided problem. Triangles ABC and DEF are similar, which means same shape, different size. Different size. If the ratio of AB to DE is 3 over 10, then find the length of EF. So what I'm going to do is I'm just going to make that x. That's what I'm solving for. I'm given some side lengths. Now AB, what we can do is we can just put the values. AB corresponds with 3. Maybe you can't quite see it. I'll make it a little bit bigger. And this is 10. So AB corresponds with 3, so I can put 3 here. And DE corresponds with 10. See this alignment right here? I'll even make these green. And I'll make the DE 10. Just to, well, maybe I should have made them the same color because they're the corresponding sides. But 3 and 10, now once I have this, I can set up a proportion using these here. In fact, I can just use this proportion here. Oops, sorry, it's getting cut off. I can use this proportion right here. 3 over 10, I'm using this, 3 over 10 is going to be equal. I know that I need x somewhere, and then the corresponding side with x is 2. Make these both purple. In fact, I'm sorry, I think this is confusing a lot of people. I'm just going to make this kind of greenish, and this greenish as well. So now we can really visually see that these are corresponding sides. So 3 to 10, now I need to figure out where the x is going to go. The x corresponds with the 10, so go ahead and predict where you think it should go. It's going to go here, and the 2 is going to go here. So 3 over 10 and 2 over x. Now when I solve for x, it's going to be 10 times 2 is equal to 3 times x, which will give me 20 is equal to 3x. Divide both sides by 3, and x is going to be equal to 20 over 3, or 6 2/3. And I believe it's meters. 20 over 3. Okay. So in summary, what did I do? I used this ratio right here, and I put x in the denominator. But I can also put these values in the triangles. The AB corresponded here, the 3, and the DE was the 10 and corresponded right here. Okay. And then once I did that, once I set up the proportion, I was able to solve for it fairly easily. Just cross multiply and then solve for x. Okay, so now please go on and solve for 3s. We're going to be solving, so BC and FG is 4 to 5. Find the length of GH here, x. Okay. Now then go on to this one here, 4s. We're going to be solving for this length, EF right here, and AB is 2, and DE is 3. All right, please submit your answers. Thank you very much, everybody. It's been a pleasure.